When we're talking about break-fix issues, when we're talking about really the more complex types of issues that you have in the more complex types of companies and products, when we're talking about thousands of barely curated articles or where you want to use your past cases in order to help solve those issues, that's when you really need precision RAG. Let's get a bit into the technology itself and explain what differentiates us and what we're doing from many of those generic solutions. Really, the first part of making this work is data cleaning and parsing. So you want to be able to take that data and have the models in place to massage that data into something that can really be worked with. So cleaning it up, removing irrelevant information, making sure obviously that no PII, no personal information exists there. And then only then, when it's really ready, you can take it over to the modeling and language processing phase. Now, what another big differentiator is our use of how we use language models in our engine. What we do is, instead of using just one approach, which is many times a lexical approach from past types of search engines, which is more the keyword-based approach, or just using a semantic approach, which uses internet-trained embeddings like we see in large language models, what we do is we combine a lot of different approaches. So lexical, semantic, local semantic, a lot of different of these models into a stack that really what that gives you is a lot of different angles to understanding what is going on in the data, both on the query side and in the result side. And that enables us to achieve very nice accuracy even when our query, as showed earlier, is an entire case or a summary of a case. A summary of a case for us in our engine is a valid query, much like a keyword query is in a portal. And we want to be able to deal with that, and we want to be able to deal with that quickly. We don't want it to require months of training in order to achieve good results. We want to be able to do it, pull the data, and go. And then comes the guardrails. Guardrails are really a critical part. Again, we all know hallucinations is a big issue, and we want to avoid that at all costs. How do we do that? So we have two types of guardrails in place. The first is in domain. So we want to understand whether the query that we're getting, whether it's from a customer or from an engineer as well, whether it's actually in the domain that's relevant to the data we have in place. So say, for example, a user comes in and asks a question, how do I walk my dog? We don't want to be answering that question with data from a cybersecurity company because obviously that's just going to hallucinate and provide irrelevant information. We want to detect that first, and that's one proprietary technology that we've been developing for quite a while now, is how to be able to detect that. The second, after the in-domain element, is say even if the query is in the correct domain, do we have information in place to actually answer the question? And again, if we do not, we want to avoid answering the question. We want to be able to say, we don't have any information on this topic, go ahead and maybe create an article or ask experts, but we don't want to just make up stuff that doesn't exist. Now the context, if we're just providing it with a 3 or 5 page long article, that is not precise enough to really be able to find the relevant information. That's A, but B, it also has to do a lot with the cost. The more tokens, the more information you're feeding to the large language model, the higher the cost. And it's an avoidable part. If we are able to find the specific passages that will power the answer, it's a much better both in precision and in cost.